Our topic today is operations with rational exponents. So our goal is to use the properties of exponents to simplify the expressions with rational exponents. On the screen here, I have a review of the properties of exponents that we looked at before. So this is just a brief review. If you've got anything raised to the 0 power, then that equals 1, as long as your base isn't also 0. If you've got two like bases and you're multiplying them together, you keep the base the same and you just add the exponents together. If you're dividing this one, previously we saw it as a fraction, so it would say x to the n over x to the m, but that means the same thing as division, as I've mentioned many times. You keep the base the same, and then you subtract the exponents, numerator minus denominator, or dividend minus divisor. If you've got a power raised to another power, then you multiply those powers together. If you've got a product being raised to a power, that power gets distributed to each piece of the product, to each factor. If you've got a negative exponent, that's the same as saying 1 divided by whatever that is with a positive exponent. Now we saw that one as a fraction also. We saw it like this. And the n should be in the bottom. There we go. Okay, if you've got a fraction, this is a fraction raised to a power, then again, that power, this is kind of the same rule as multiplying. The power goes to both the numerator and the denominator. And if you have a base raised to a fractional exponent, well, that's really just a radical. The denominator of the radical is your index. All right, so we have a couple of warm-up problems here. The best thing to do at this point would be to pause the video and try these warm-up problems and then come back and check your answers. All right, so the answers you should have come up with for part A there was a to the 5th power. You should have done the operation inside first, which would be adding those powers together, and then multiply it by the power on the outside. So that would be a to the 10th to the 1/2. And 10 times 1/2 is 5, so it's just a to the 5th. The second one was a division problem. You should have gotten 1 over x to the 8th, y to the 6th. Remember, to deal with dividing by fractions, you start by changing it to multiply by the reciprocal of the second one. And with this one, we also had some negative exponents, so we were moving those around to clear them. The third one, most everything canceled out in there. You just end up with a y over 3z. Alrighty, so now we're going to apply these rules to non-integer exponents. So our exponents are going to be rational numbers or fractions. We're going to simplify completely, and the answer should only include positive exponents for all of these. So I think I'm going to make this just a little bit bigger so I can see it better. Y'all can probably see it just fine because you have lovely young eyes. All right, here we go. Okay, so for this first one, I've got x's happening in multiple places. I've got 2x with exponents in the numerator and 1x with an exponent in the denominator. So if I'm just strictly following the rules with this, I'm going to keep the x, keep the base the same. The rule says that I'm supposed to add the ones that are multiplied together. So 2/3 plus 3/5. And I'm supposed to subtract the one that it's being divided by. So minus 4/3. So with this, I can then combine my like terms here. Now, one thing I notice is that I've got two fractions here. Oh, first of all, we're doing addition and subtraction, which means we do have to have common denominators. But I do notice that the first fraction and the last fraction here are actually, they already have the same denominator. So I'm going to do a little bit of rearranging just to make things easier for me. This 4/3 on the end, I'm treating it like it says plus a negative 4/3. So when I move it around using the commutative property, I can say this would be plus negative 4/3, and then the plus 3/5. So that was using commutative property. Now I'm going to use associative property here, group these two together. And then I can perform this addition. So since the denominators are the same already, I just keep the denominator and then I add the numerators. So 2 plus -4 is -2. All right, next up, I just need to perform this addition here. So I'm going to do a little bit of scratch work out to the side. Pick a pretty color there. So my job is to take -2/3 and add 3/5. This is my scratch work, so I'm not including this. Not including this as part of one of my steps here. So when I add these together, I do have to have a common denominator. My smallest common denominator for 3 and 5 would be 15. So I would start by changing both of these fractions into fractions with a 15 denominator. The first one, I make that happen by multiplying by 5/5. So my new numerator would be -10. The second one, I have to multiply the 5 by 3. So the top would be 3 times 3, which is 9. And now I can add those together, keeping the denominators the same, and then adding the numerators. So -10 plus 9 would be -1. All right, ready to take that back to my problem now. So now I'm going to replace the exponent over here with -1/15. Now I'm almost done. I only have x occurring one time here, and there's no excessive operations going on here in the power. So all I need to do now is take care of the negative. I ran out of room there, so I'm just going to make another column. That negative exponent tells me that I'm supposed to put it under 1. So this would be 1 over x to the 1/15th power. And this would be my simplified version of this original problem. Okay, moving on to the second one over here. This time I have more than one variable happening. I've got x's and y's. Looks like everything's got powers on them. I've got fractional powers on everything. But I also noticed the second big fraction that I have here, has a power on the outside. So what I want to do first is I want to deal with the inside of this fraction. And I think I can probably go ahead and deal with the inside of this one I can deal with this fraction too, since it's got x's in the numerator and the denominator, and same for the y's. I want to go ahead and make them as simple as possible. So starting with the x's over here, the x's are being divided, so that means I'm supposed to subtract their powers. So 3/5 minus 8/5. Same thing for the y. 3/2 minus 1/2. And I think before I move on to the parentheses, I want to go ahead and simplify those a little bit more here. That was a 5. All right, we are subtracting fractions, so we do have to have the same denominator, and they do. So then I can just subtract the numerators. This is an 8, a little bit hard to see. 3 minus 8 is -5. And over here, 3/2 minus 1/2, so the denominator is a 2. And I just subtract the numerators, so 3 minus 1 is 2. Now -5 over 5 would be a -1. And 2 over 2 would be a 1 also. So this one is not necessary to write. The -1 I did need to write because it's negative. I'm going to go ahead and move on to the parentheses now here. So I'm going to save that 7/3 for last. 7/3 that's on the outside there. So I'm going to simplify what's on the inside first. Once I've got this as simple as I can get it, then I'll apply that 7/3. All right, so again, I've got x's in the numerator and in the denominator. So I'll be subtracting. So this would be 3/7 minus -5/7. And it looks like I need more room there. Let's see if I can figure out how to erase, or at least shift things over. Oh, that came out weird. I'm just going to erase it. There we go. Okay, here we go. All right, so now I'm going to do the same with the y's. So I've got 5/7 minus 2/7. And then I've got that 7/3 power on the outside. I'll continue simplifying here. So 3/7 minus a negative 5/7 would be like 3 plus 5. So that would be 8/7. And then on the y, I've got 5/7 minus 2/7. So that would be 3/7. And then I still have that 7/3 power on the outside. Okay, now my next step after this would be to apply this 7/3 power that was on the outside to each of the factors on the inside here. So x to the 8/7 to the 7/3. I'm going to do a little work out to the side again, a little bit of scratch work. So I'm doing 8/7 times 7/3. And so this is multiplying fractions. And for multiplying fractions, you don't need the same denominator. You just multiply straight across. So this would be 8 times 7 is 56, and 7 times 3 is 21. And then we would need to reduce it if we can. Now, 56 and 21 both have 7 as a factor, so we can divide them both by 7, and that would give me 8/3. So my new power on x would be 8/3. I think it was that color I was using. Okay, so x to the 8/3 power. My pen is not working nice today. Okay, I'm going to do the same thing with the y's. So a little bit of scratch work out to the side there for that one. Let's use red. So we're multiplying 3/7 times 7/3. And once again, we just multiply straight across. Multiplying fractions is the easy operation. So 3 times 7 is 21. 7 times 3 is also 21. And then I've got 21 divided by 21, which is 1. So this is just a y to the 1, which again, I didn't really have to write, but I'm not to the end anyway, so I'm going to go ahead and write it in there. All right, now I've got some multiplication going on. So when you're multiplying things with like bases, you're going to add the powers together. So this would be a -1 plus 8/3. And for the y's, it would be y to the power of 1 plus 1. I'm going to go ahead and write that as y squared. And again, I ran out of room, so I'm going to make another column here. Okay, so the y squared is going to stay just like it is. If I can make that really look like a 2. For the x, I've got a -1 plus 8/3. So I need to rewrite that. In order to add, I need to rewrite that 1 as, the -1 as something with a 3 denominator. So that's going to be a -3/3 plus 8/3. Again, this is just scratch work over here. So the denominators are the same, so that stays. And I just add the numerators. So -3 plus 8 is 5. So this would be x to the 5/3 power, y squared. And this would be my simplified version of this one. All right, moving right along. Okay, so for this next one, I've got some really interesting things going on inside there. Let me find a different color again. I guess we'll go green this time. All right, so for this one, inside the parentheses, I have x's for my bases. I have y's for my bases. But this time I've got some variables, some n's with the powers as well. So that's going to make this problem a whole lot more interesting. We're still going to follow the same rules though. So the x's, I'm going to keep those together. And I'm going to follow the rule for what to do with the powers. Now the rule says I take the numerator's power and I subtract the denominator's power. Now since the denominator's power is a binomial, I'm going to go ahead and put it in parentheses so I make sure I'm subtracting the whole binomial there and not just the first term of it. Same thing for the y's. So for the y's, I'm going to keep the base the same, and I'm subtracting the powers. Numerator minus denominator. This time the denominator's power is a monomial, so I do not need the parentheses for that one. And I'm going to put the whole thing in parentheses still, and I'm going to keep that 1/3 power on the outside. All right, now I need to simplify inside here. The y is already simplified, so I'm just going to keep that one. 3n minus 12. And the 1/3 power on the outside. For the x, I need to simplify this here. So that would start with distributing the negative. So that's going to make it say minus n and plus 2. So if I take this, 4n minus n would be 3n. And 1 minus negative 2 would be plus 3. Lastly, I need to deal with this power on the outside here. So this power is going to get distributed to each of the exponents. And when this 1/3 gets multiplied by 3n plus 3, it's actually going to multiply each of these terms by 1/3. So 3 times 1/3 is 3/3, which is just 1. So this is just n. And this 3 times 1/3 is also 3/3, which is also 1. Now I'm doing 1/3 times 3n minus 12. Again, 1/3 times 3n would be 3 over 3, which is just n. And then 1/3 times 12 would be 12/3, which is 4. So this would be n plus 1 times, x to the n plus 1 times y to the n minus 4. That's as far as we go. All right, one last one. So for our last one here, we have just two expressions being multiplied together. I see that there are coefficients this time, and this time the coefficients are fractions also. Now I know from the previous problems that we've done, when you have coefficients being multiplied together, you're just following regular multiplication rules. So we're just going to multiply 2/3 times 3/8, and that's just fraction multiplication. So just straight across the top, 2 times 3 is 6. 3 times 8 is 24. And then we'll reduce that in our next step. Then for our x's, we've got x to the 3/4 times x to the 7/4. So our rule says we're supposed to add those powers. So 3/4 plus 7/4. Same for the y's. So we're going to add the powers. So that would be 4/3 plus 4/5. And now we just need to perform this addition, reduce this fraction, perform this addition. So here we go, 6 over 24, both are divisible by 6, so that's 1/6. And for our x's, we are adding fractions, which means we do need to have a common denominator. They are already the same, so we'll just keep them. And then add the numerators. 3 plus 7 is 10. And for the y's, the denominators are not the same. So we're going to have to fix this one before we can add them. So I'm going to do scratch work for this one. Make another color. We'll go out to the side here. So for 4/3 plus 4/5, our smallest common denominator would be 15. So to turn this 3 into a 15, I'd have to multiply by 5. So I do the same to the numerator, so that would be 20. And to turn this 5 into a 15, I had to multiply by 3. So I do the same to its numerator, so that would be a 12. Now that the denominators are the same, I can add the numerators. Keep the denominator the same, add the numerators. So 20 plus 12 is 32. And then I would reduce this if I can, but 32 and 15 actually have no factors in common. So this one is, you're ready to go back to my problem here. So 32 over 15. It's kind of an ugly fraction, but they can't all be beautiful. Okay, so I do have one more step because 10 over 4 can be reduced. 10/4, both numerator and denominator are divisible by 2, so that would be 5/2. And as we mentioned before, for the y's, for the power on y, 32/15, there are no common factors with 32 and 15, so it just stays. So this would be our result. All right, you'll work on some practice on this in class tomorrow. So that way, if you have some trouble, you'll have the opportunity to talk with me about it.